Welcome to your math channel. Today is a special lesson. I'm going to talk about the Pythagorean theorem, one of the most famous theorems in mathematics with over 2,500 years of history, involving triangles, philosophy, and even a secret society. Besides learning about this incredible story, you'll also find out where we use this theorem in real life. After all, how many times have we heard, "Why am I studying this?" Well, today you're going to understand. Pythagoras was born around 570 BC on the island of Samos, in Greece. He traveled a lot, studied mathematics in Egypt and Babylon, and ended up founding a school in Croton in southern Italy. But this wasn't an ordinary school. Pythagoras' followers, called the Pythagoreans, lived as a closed community with strict rules, believing that everything is number. They mix science, philosophy, music, and yes, mathematics. Although we don't have anything written by Pythagoras himself, it's believed that he or his disciples were the first to mathematically prove the theorem that bears his name. What the Pythagorean theorem proves is that in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. The Pythagorean theorem is so famous that there are more than 370 different proofs of it. Did you know that a US President, James Garfield, created a proof using trapezoids? And in ancient times, Egyptian builders used the so-called 3, 4, 5 rope to create perfect right angles, stretching a rope with several equally spaced knots. It might seem like Pythagoras is stuck in math textbooks, but his theorem shows up all the time in real life. Now let's look at an example from construction. A bricklayer needs to make sure that one wall is perfectly perpendicular to another. In other words, the bricklayer built a wall that's 3 meters long and wants to build another one here that's 4 meters, but he hasn't built it yet. He needs to make sure that this second wall is in a straight line, forming a perfect right angle. So he puts a mark here, and as he measures from that mark to here, it has to be, let's call it A. That will be the hypotenuse, and he can use the formula a squared equals 3 squared plus 4 squared, applying the Pythagorean theorem. So it'll be a squared equals 9 plus 16. A squared equals 25. Here it's an exponent, so when it moves over, it becomes a root. So it'll be a equals the square root of 25. Equals 5. The hypotenuse has to be exactly 5 meters. If he measures and finds 5 meters, it's correct. He can then go ahead and build the wall. Now, let's say he marked it here. When he measures, it'll come out to 5.1. He already knows that's wrong, so he needs to move it up a bit. Or if by chance he had done it like this more inward, it would come out to 4.8 meters, for example, for the hypotenuse. So this way he can know if this second wall is really straight, forming a right angle. And here is the application of the Pythagorean theorem in civil construction. Now let's go to a second example, an engineering situation. An engineer wants to know the height of a pole. Let's say here we have a pole and he wants to calculate the height of the pole, but without having to climb a ladder to measure it. Let's say the engineer is here and he measured with a laser that from the base of the pole to where he is standing on the ground, it's exactly 8 meters. He points the laser from the base to the top of the pole and it measures 10 meters. So what will the height be? He just needs to apply the Pythagorean theorem here, where the hypotenuse, which is 10 squared, equals 8 squared plus the other leg squared. So it becomes 100 equals 64 plus the leg squared. 100 minus 64, the 64 moved over here, so the plus sign changes to minus, is equal to the leg squared. 100 minus 64, 36 is equal to the leg squared. Here, since it's an exponent, when it moves over it becomes a root, so it turns into the square root of 36 equals the leg, 6 equals the leg. So he figures out the height of the pole, which is 6 meters, without needing to climb a ladder or anything. So here you see a real-life application to find out the height of a pole, which could be a building or anything else. All you need to do is set a fixed point on the ground, know the distance from where you are to what you want to measure, the height, and then point to the top, and you can figure out the height by doing the calculations using the Pythagorean theorem. Now let's look at another example. A boat is 5 kilometers north of a lighthouse. Let's say this is land and here's the lighthouse. The boat is 5 kilometers to the north. I'll put 5 km here and 12 kilometers to the west. 12 km. What is the distance to the lighthouse? All you have to do is measure here C, which is exactly the hypotenuse. Here we have a right angle, so he just needs to find the hypotenuse. He's not going to go 12 kilometers to the side and then down another 5, making 17 kilometers. That doesn't make sense if he has a shorter path. So what is the distance? Let's do the calculation. A squared equals 12 squared plus 5 squared. So a squared equals 144 plus 25. A squared equals 169. Since it's an exponent, it becomes a root, so a, which is the hypotenuse, equals the square root of 169. So a equals 13. What's the answer here? What's the distance? The answer then is 13 kilometers, which is the distance from the boat to the lighthouse. Here's another real-life application in a navigation and GPS situation, calculating the straight line distance. Now let's go to another example. Let's apply this to find out the diagonal of a screen. Let's say you can't measure it right now, but you know from the specs what the height and width of the screen are, and it's 68 centimeters tall and 120 centimeters wide. What would the diagonal be here? You just need to apply the Pythagorean theorem. It'll be a squared equals 120 squared plus 68 squared, which is a squared equals 14,400 plus 4,624. So a squared equals 19,024. Now, as a power, it goes to the other side as a root, so it'll be a equals the square root of 19,024. What is the square root of 19,024? Yeah, a will be approximately 137.9 centimeters. So you know that's the diagonal. How do you convert that to inches? Just divide 137.9 by 2.54. That will give you approximately 54.33. So your TV is 54, or it can even be rounded up to 55 inches in the TV's commercial specs. Here we showed how to apply the Pythagorean theorem in real life in various situations. If you enjoyed it, leave a like, subscribe to the channel, and leave a comment. I'll end the video with a quote from Pythagoras. Educate the children so that it won't be necessary to punish the adults. Thank you very much for watching, and see you in the next video.